Alright, my dear JEE aspirants, hope you're preparing well for April shift. January shift is already over. We started solving the PYQs of January shift 2026 JEE main. Already covered limits, continuity and differentiability, trigonometric functions, complex numbers. Now I'm dealing with quadratic equations. We'll see the number of questions appeared from different topic of this quadratic equations. Actually, nature of roots, we got one question. Location of roots, one question. Okay. Then we have questions based on finding the number of real roots, sum of the roots, such kind of questions, 3 are there. Then we have one word problem. Okay. And also we have 4 questions based on the relationship between the roots and the coefficients. Altogether, we have 10 questions from this topic. Okay. The first question is this: sum of all the roots of this equation, x minus 1 the whole square minus 5 into mod x minus 1 plus 6 equal to 0. So x minus 1 the whole square is same as mod x minus 1 the whole square. So I can put t is equal to mod x minus 1 and make it as a quadratic in t. So x minus 1 the whole square is same as mod x minus 1 the whole square. Mod x minus 1 the whole square minus 5 times mod x minus 1 plus 6 equal to 0. What you do is put t is equal to mod of x minus 1. Put t is equal to mod of x minus 1. So that I get a quadratic in t. Correct? So this becomes t square minus 5t plus 6 is equal to 0. That is, if you factorize this, you get t minus 2 into t minus 3 is equal to 0, which gives a into b 0 implies either a equal to 0 or b equal to 0. T is equal to 2 or t is equal to 3. When t is equal to 2, find out the corresponding value of x. When t is equal to 2, we have mod x minus 1 is equal to 2. Mod x minus 1 is equal to 2 means x minus 1 is equal to 2 or x minus 1 is equal to minus 2. Because mod of 2 is 2, mod of minus 2 is also 2. 2 values will satisfy. X minus 1 is 2 means x is equal to 3. Here this gives x minus 1 is equal to minus 2 because x equal to minus 2 plus 1, this is minus 1. Correct? So x equal to 3 or x equal to minus 1 I am getting. When t is equal to 3, find the corresponding value of x. When t is equal to 3. When t is equal to 3, mod of x minus 1 is equal to 3. This gives x minus 1 is equal to 3 or x minus 1 is equal to minus 3. X is equal to 3 plus 1, 4. Or x is equal to minus 3 plus 1, which is minus 2. So we get 4 solutions here. They ask to find sum of all the roots of this equation. Correct? Therefore, sum of the roots is sum of all the roots of this equation is 3 plus minus 1, 3 plus minus 1 plus 4 plus minus 2. Minus 1, minus 2, minus 3. Minus 3 plus 3 will cancel. So we get 4 as the answer. Sum of all the roots of this equation is 4. Please make a note of this. A quite simple question. Writing x minus 1 the whole square as mod x minus 1 the whole square. Because mod x square is same as x square. So x minus 1 the whole square is same as mod x minus 1 the whole square, and putting t equal to mod x minus 1, writing it as a quadratic in t, finding the values of t, hence finding the values of x. Hope it's clear. Question asked on 21st of January 2026. On to the next one. The second question here. The positive integer n for which the solutions of the equation given by this x into x plus 2 plus x plus 2 into x plus 4 plus etc. x plus 2n minus 2 into x plus 2n is equal to 18 by 3 are two consecutive even integers is how much? So the roots of this equation are two consecutive even integers. Any two consecutive even integers always differ by 2. That you must know. Suppose alpha and beta are the roots of this equation. I can write mod of alpha minus beta as 2. So two consecutive integers, even integers are 4 and 6, 98 and 100, 50 and 52, correct? 64 and 66 like that. Any two consecutive even integers, okay? So they differ by 2. I can tell absolute difference between the two consecutive even integers is always 2. Suppose alpha and beta are the roots of this equation. I can write the condition that mod of alpha minus beta is equal to 2. Mod of alpha minus beta is equal to 2. So the given equation, I can express in terms of summation here. So how to express this in terms of summation? Because there is many brackets here, correct? X into x plus 2, x plus 2 into x plus 4, like that. Last bracket is x, last term is x plus 2n minus 2 into x plus 2n. There are n brackets. I'll express this in terms of summation. The given equation could be written as summation r is equal to 1 to n x plus 2r minus 2 x plus 2r minus 2 into x plus 2r is equal to 18 by 3. Multiply it. I'll use summation concept also here. Simplify this first. Summation r is equal to 1 to n. X into x is x square plus 2r minus 2 into x. X into x I multiplied. 2r minus 2 into x. X into 2r, correct? X if you take common. X into 2r minus 2 plus x into 2r. So 2r minus 2 plus 2r, that becomes 4r minus 2. 4r minus 2, correct? X into 2r plus x into 2r minus 2. X is common. 2r minus 2 plus 2r, which is 4r minus 2. Then what is left is the constant term I can multiply. 2r minus 2 into 2r. 2r into 2r minus 2. When you multiply these two, 2 into 2. 1, 2 is common here. So I write 4 into r minus 1. Correct? 4r into r minus 1 is equal to 8n divided by 3. Correct? 2r minus 2 into 2r is 2 into 2 is 4. 2 is common from this. That 2 into this 2 becomes 4. So when 2 is taken out, r minus 1 remains r into r minus 1. So now we'll use expansion now. So, summation will multiply inside. I mean, take the summation for each of these terms. Summation of x square, that is r varies from 1 to n. That means there are n terms. Summation when it is applied to x square, this becomes nx square. Nx square. X square is present n times. Here what we can do is you can take 2 outside here. If you take 2 outside, 2x into, it becomes summation of 2r minus 1. Summation of 2r minus 1 is nothing but sum of the first n odd natural numbers. We know that sum of the first n odd natural numbers is n square. Correct? If 2 is factored out, what remains is 2x. 2x into summation of 2r minus 1. Summation of 2r minus 1 is nothing but n square because 2r minus 1 represents odd natural numbers. Summation of 2r minus 1 is sum of the first n odd natural numbers, which is equal to n square. Plus 4 into summation of r square minus summation of r. This becomes 4 into, what I get is summation of r square minus summation of r, which is equal to 8n divided by 3. Summation of r square minus summation of r I can simplify and write. Summation of r square is n into n plus 1 to n plus 1 by 6. I'll show the steps here. Summation of r square n into n plus 1 to n plus 1 divided by 6 minus summation of r is n into n plus 1 divided by 2. N into n plus 1 divided by 2. Simplified. what we get? If you simplify this, n into n plus 1 divided by 2 is common. So what remains is 2n plus 1 divided by 3 minus 1. Correct? This is equal to n into n plus 1 divided by 2. 2n plus 1 minus 3, which is 2n minus 2 divided by 3. Correct? 2n plus 1 minus 3, which is 2n minus 2. 1, 2 can be cancelled here from this. If you take 2 common and cancel. So what remains is n into n plus 1. This becomes n minus 1. N plus 1 into n minus 1 becomes n squared minus 1 divided by 3. So summation of r square minus summation of r is going to be n into n square minus 1 divided by 3. Correct? So that is, I can write this as nx square plus 2x into n square plus 4 into, the simplified form of this we got it here, n into n square minus 1 divided by 3. N into n square minus 1 divided by 3 minus 8n divided by 3 is equal to 0. I can divide this entire equation by n. N is common throughout, so divide the entire equation by n. So what we get is x square, correct, plus 2nx plus 4 by 3 into n square minus 1 minus 8 by 3 is equal to 0. Dividing throughout by n. This is quadratic in x. The alpha and beta are the roots of this equation. Given that the two consecutive even integers as the roots of this equation, suppose alpha and beta are the roots of this equation, according to the question given, mod of alpha minus beta is equal to 2. Correct? Given absolute difference between the roots of the equation as 2, because they told the two consecutive even integers are the roots of this equation. Okay? I have to find the positive integer n. So mod alpha minus beta is 2. So from this I can do squaring on both sides, so that I can use alpha minus beta the whole square as alpha plus beta the whole square minus 4 alpha beta, so that I can express in terms of sum of the roots and the product of the roots. So using this equation, squaring on both sides, we get alpha minus beta the whole square is equal to 4. Alpha minus beta the whole square is equal to 4, which is alpha plus beta the whole square minus 4 alpha beta. Correct? Sum of the roots is minus b by minus coefficient of x by coefficient of x square. Sum of the roots is minus 2n divided by 1, which is minus 2n. So minus 2n the whole square. Minus 2n the whole square. Minus 4 into alpha into beta, the product of the roots is constant term divided by coefficient of x square. This is a constant term divided by coefficient of x square is 1. That is, denominator is 1, no need to write that. So 4 by 3 n square minus 1 minus 8 by 3. 4 by 3 into n square minus 1, n square minus 1 minus 8 by 3. Correct? Is equal to 4. Simplify this. Minus 2 in the whole square is 4n square minus 4 into 4, 16 divided by 3 into n square minus 1 minus into minus plus 32 divided by 3 minus 4 is equal to 0. Simplify this further. Hope it's correct. The substitution. Correct? 4 by 3 into n square minus 1 minus 8 by 3. Now we can multiply the entire equation by 3. So this becomes 12n square minus 16n square plus 16 plus 32 minus 4 into 3 minus 12 is equal to 0. Correct? So what we get here? This is 16 plus 32. 16 plus 32 is 48. 48 minus 12, which is 36. Correct? Minus 4n square plus 16 minus 12, 4 plus 32, 36 equal to 0. Get n square is equal to 9 from this. Correct? 4n square equal to 36. N square is equal to 9. N is equal to 3 because they told n is a positive integer. N is a positive integer. Therefore, I take the positive value. Actually, plus or minus 3, but take only positive value. because n is a positive integer. It's mentioned in the question. So the value of n is 3. Question asked on 21st of January 2026, evening shift. Please make a note of this. Little bit lengthy question. Okay. Please make a note of this. Move on to the next one. Question number 3 we have. Alpha and beta are the roots of this equation such that 1 lies between the roots alpha and beta. Set of all possible values of a is what? This is a question based on location of roots. Observe that coefficient of x square is positive. Any quadratic is representing the parabola. Quadratic in x is the equation of parabola. Because coefficient of x square is positive here, the parabola is opening upwards. The parabola looks like this. Alpha and beta are the roots of this equation. Where it intersects the x-axis are the roots. 1 lies between the roots. 1 is here. Okay. 1 lies between the roots. Because a is positive, coefficient of x square is positive, the parabola is opening upwards. 1 lies between the roots alpha and beta. That means the actual condition is coefficient of x square into f of 1 should be negative because height is below the x-axis. This height is below the x-axis. Already coefficient of x square is 1. It's positive. So my condition is actually a into f of 1. A into f of that value. That value is 1. No? 1 is a given condition. A into f of k. If the quadratic equation is ax square plus bx plus c equal to 0, this is a quadratic equation. Okay. If k lies between the roots, alpha and beta, okay, in that case, the condition is a into f of k should be less than 0. The condition for the k is some number which lies between the roots alpha and beta. The condition is a into f of k. This should be negative. A means coefficient of x square. K is a given number which lies between the roots. A means coefficient of x square. Coefficient of x square is already 1. So 1 into f of 1, that should be negative. Here 1 into f of 1 should be negative. Take this quadratic as f of x. So f of 1 means put x is equal to 1 in this. 1 square plus 2a into 1 plus 3a plus 10. Okay. That is 1 square plus 2a into 1. 2a into 1 plus 3a plus 10 is less than 0. 3a plus 2 is 5a, correct? 10 plus 1, 11 is less than minus 11, or you divide by 5 on both sides. A is less than minus 11 by 5. So A is less than minus 11 by 5 means left side of minus 11 by 5 on the number line. If you take minus 11 by 5, A is less than minus 11 by 5 means left side of minus 11 by 5 excluding minus 11 by 5. So minus infinity to minus 11 by 5. The problem based on location of roots. This is a question based on location of roots. There are 6 cases actually on location of roots. Both the roots are less than a given number k. Both the roots are greater than a given number k. K lies between the roots. Exactly one root lies in the interval k1, k2. Both the roots lies in the interval k1, k2. Like that we have different cases. One root alpha is less than k1 and another root beta is greater than k2. Like that 6 cases we have. This is the root 1 which lies the number 1 which lies between the roots. A number k lies between the roots. That concept here. Location of roots. So answer is 4th option. Move on to the next one. We have question number 4. Number of distinct real solutions of this equation are based on the modulus function. Here we should see the critical points where modulus function becomes 0. Such points are called critical points. Mod x plus 4 becomes 0 at x equal to minus 4. Mod x plus 2 becomes 0 at x equal to minus 2. So I will discuss the cases here. Cases. The critical points are x plus 4 0 means x equal to minus 4. X plus 2 0 means x equal to minus 2. So I will divide the number line into 3 intervals. X less than minus 4, x greater than or equal to minus 4, less than minus 2 and x greater than or equal to minus 2. 3 cases I will take. Case 1 we have. Case 1. X is less than minus 4. X is less than minus 4. So take minus 5. Minus 5 plus 4, negative, correct? Terms inside the mod is negative. In that case, x plus mod x plus 4 becomes minus of x plus 4. Given equation becomes, if you take minus 5, terms inside the mod, minus 5 plus 4, minus 1, negative. Terms inside the mod is negative, right? So mod of x plus 4 becomes minus of x plus 4. X into minus of x plus 4. So minus x into x plus 4. When you put minus 5 here, minus 5 plus 2 is minus 3. Terms inside the mod is negative. That means x plus 2 is negative. X plus 2 is negative means mod x plus 2 is minus of x plus 2. So minus 3 into x plus 2 it becomes. Minus 3 into x plus 2 plus 10 is equal to 0. Simplify this. What we get? Minus x square minus 4x minus 3x is minus 7x. Minus 3 into 2, minus 6 plus 10, which is 4, correct, equal to 0. Minus x square, minus 4x minus 3x is minus 7x, minus 6 plus 4, that is 10. Or you multiply the entire equation by minus 1. X square plus 7x minus 4 equal to 0. From this, you can solve this by using formula method. X is equal to minus b plus or minus root of b square minus 4ac, 4 into 1 into minus 4, correct, divided by 2a, 2 into a is 1. So what do you get? This is equal to minus 7 plus or minus 49 plus 16, which is 65, root 65, divided by 2, correct. Root 65 is 8 point something. 8 point something minus 7 is 1 point something. 1 point something by 2 is nearly 0.5. 0.5 is less than minus 4 is not possible. So positive value does not satisfy. A negative value will satisfy, I think. Minus root 65 we take. Minus 7 minus 8 point something. Minus 15 point something. Minus 15 point something by 2 is minus 7 point something. Is a number less than minus 4. Satisfies. Here x equal to minus 7 minus root 65 divided by 2 is going to belong to the interval minus infinity to minus 4. So this is accepted and this is rejected. Minus 7 plus root 65 divided by 2 does not lie in the interval minus infinity to minus 4. So only one root exists. This root does not exist. This is rejected. This is accepted. Correct? So one root we get for x less than minus 4. Because this does not lie in the interval minus infinity to minus 4. This turns out to be positive value. So something nearly 0.5 get. Now I'll take x to lie between minus 4 and minus 2. If x lies between minus 4 and minus 2, what about x plus 4 and x plus 2 is see first. Suppose you take minus 3. Minus 3 plus 4 is 1. So x plus 4 is positive. Mod x plus 4 becomes x plus 4 only. Case 2, right? Case 2. Case 2. This is for x to lie between minus 4 and minus 2. Minus 4 less than or equal to x less than minus 2. Correct? Take a number, say minus 3. Minus 3 you take. Minus 3 if you take, minus 3 plus 2, minus 1. This is negative, this is positive. Given equation becomes x into x plus 4. Correct? If you take minus 3 in this interval and substitute, minus 3 plus 4 is 1, positive. X plus 4 is positive. Mod x plus 4 is x plus 4. Mod x plus 2 becomes minus of x plus 2. Minus 3 times x plus 2 plus 10 is equal to 0. So what we get is x square plus 4x minus 3x, that is plus 6, minus 6 plus 10, that is 4. Like this we get x square plus 4x minus 3x is plus 6, minus 6 plus 10 plus 4. Here if you observe, b square minus 4ac is negative. Roots are going to be imaginary here. No real roots exist here. B square minus 4ac if we calculate for this quadratic. B square, 1 square 1 minus 4 into 1 into 1. Correct? 1 into 4, sorry. 1 into 4, that is, you get b square minus 4 into 1 into 4. 1 minus 16 minus 15, correct? Minus 15. So no real roots. No real roots exist in this. No real roots. Last case will take for x is greater than or equal to minus 2. If you take x greater than or equal to minus 2, case 3 for x greater than or equal to minus 2. X greater than or equal to minus 2. In that case, what happens? If you take a number, say 0, 0 plus 4 positive, 0 plus 2 positive, x plus 4 is positive, so mod x plus 4 is x plus 4. X plus 2 is positive, mod x plus 2 is x plus 2. Given equation becomes x into x plus 4, x into x plus 4, correct? Plus 3 into x plus 2, 3 into x plus 2 plus 10 equal to 0. So what we get is x square, 4x plus 3x, 7x, 3 into 2, 6, 6 plus 10, which is 16, equal to 0. Here also if you observe b square minus 4ac, b is 7 here, 7 square is 49, minus 4 into a into c, correct? 49 minus 64, which is minus 15, less than 0, no real roots. No real roots exist because b square minus 4ac is negative. Roots are imaginary. So here also we don't get any roots. Case 2, case 3 we don't get any roots. In case 1, 2 roots we got. 1 root is rejected because that root does not lie in this interval. So only one real root exists. The number of distinct real roots of this equation is 1. Only one real root, which is the question asked on 22nd of January 2026. Please make a note of this. Move on to the next one. Question number 5 we have. Alpha, beta are the roots of this quadratic equation. Lambda belongs to z, the set of integers, with condition given mod of beta minus alpha to lie between half and 3/2, including the endpoints. Sum of all possible values of lambda I have to find out. So from the given equation, if alpha and beta are the roots of this equation, 12x square minus 20x plus 3 lambda equal to 0. Correct? Alpha and beta are the roots of this. So what you can write, alpha plus beta is equal to minus b by minus of minus 20 divided by 12, which is 5 by 3. Correct? And product of the roots, alpha into beta is equal to c by 3 lambda divided by 12, which is lambda by 4. Lambda by 4. Correct? 3 lambda by 12, that is c by a. This is minus b by 20 by 12, which is 5 by 3. So use this condition. Given half less than or equal to mod of beta minus alpha, same as mod of alpha minus beta, both one in the same, less than or equal to 3/2. Squaring on each of this, 1/2 square is 1/4, less than or equal to alpha minus beta the whole square or beta minus alpha the whole square, both one in the same. You must know that mod alpha minus beta is same as mod of beta minus alpha. So I am writing like this. Instead of mod beta minus alpha, I wrote mod alpha minus beta, less than or equal to 3/2 square is 9/4. From this, 1/4 is less than or equal to alpha minus beta the whole square is alpha plus beta the whole square minus 4 alpha beta, the basic algebraic identity expressing alpha minus beta in terms of alpha plus beta and alpha into beta. Alpha plus beta 5/3. Substitute the values of sum of the roots and the product of the roots. Alpha plus beta is 5/3. 5/3 square is 25 divided by 9 minus 4 into alpha beta. Alpha beta is lambda by 4. 4 into alpha beta is going to be lambda, less than or equal to 9/4. Correct? Subtract 25 by 9 from each of this. Correct? So what you get is 1/4 minus 25 divided by 9 less than or equal to, subtract 25 by 9. So minus lambda remains 9/4 minus 25 divided by 9. Take LCM, 4 and 9, LCM is 36. 4 9s are Correct? 9 fours are 4 into 25 is 100, less than or equal to minus lambda less than or equal to 4 and 9 LCM is 36. 4 nines are 9 into 9 is 81. 9 into 4, 4 into 25 is 100. Correct? So what we get is minus 91 divided by 36 less than or equal to minus lambda less than or equal to minus 19 by 36. Or you multiply the entire inequation by minus 1 to get rid of the minus sign. So I'll reverse the inequality and write 19 by 36 is going to be less than or equal to lambda less than or equal to 91 by 36. 19 by 36 is a number slightly greater than 0.5. Correct? 18 by 36 is 0.5. 19 by 36 is slightly greater than 0.5. So the possible values of lambda is integer they told. Lambda lies between 0.5 something and this is 2 point something. Since lambda belongs to z, the possible values of lambda in this interval are the possible values of lambda are 1 and 2. Correct? This is 0 point something, 0.5 something, 1 and 2. This is 2 point something. So possible values of lambda are 1 and 2. So that sum of the possible values of lambda 1 plus 2 is equal to 3. Answer is option 3. Sum of the possible values of lambda 1 plus 2 is equal to 3. Question asked on 22nd of January 2026 evening shift. Please make a note. For the next one, question number 6. Alpha and beta, alpha less than beta are the roots of this equation. Want to find root of beta by alpha plus root of alpha into beta. So, by careful observation, we can see that I can write this equation in terms of quadratic in mod of root x minus 3. By careful observation is required in this problem because you can see mod of root x minus 3 here. Its coefficient is minus 2 plus root 3. Here, x minus 6 root x plus 9, I'll write in one bracket. See, if you observe x minus 6 root x plus 9, which could be written as root x square minus 2 into 3 into root x plus 3 square. It is in the form of a square minus 2ab plus b square, which is a minus b the whole square. Root x minus 3 the whole square. Root x minus 3 the whole square is same as mod of root x minus 3 square, because x square is same as mod x square. Completing the square, taking this and this in one bracket, I could complete the square and I write in terms of mod of root x minus 3 the whole square. So writing these three terms, these two and plus 9, I get root x, mod of root x minus 3 square. Mod of root x minus 3 square. Here I'll take minus sign common. If you take minus sign common, it becomes minus 2 plus 3 is minus of 2 minus root 3 into mod of root x minus 3. Correct? X minus 6 root x plus 9 minus 2 root 3 equal to 0. Minus 2 root 3 is equal to 0. Correct? This is quadratic in mod of root x minus 3. Put mod of root x minus 3 as some number lambda or t, whatever. Put mod of root x minus 3 is equal to lambda. Therefore, the given equation becomes lambda square minus of 2 minus root 3 into lambda minus 2 root 3 equal to 0. Correct? So, that is lambda square minus 2 lambda plus root 3 lambda minus 2 root 3 equal to 0. Opening the bracket. So from this we can take lambda common. So what remains is lambda minus 2 from the first two terms. From the third and fourth term, root 3 is common. Lambda minus 2 remains again. Again lambda minus 2 is common from this. Lambda minus 2 into lambda plus root 3 equal to 0. Lambda minus 2 equal to 0 or lambda plus root 3 equal to 0. This gives lambda is equal to 2 or lambda equal to minus root 3. Lambda is what? mod of root x minus 3, correct? Mod of root x minus 3. Mod of root x minus 3 is equal to 2, or mod of root x minus 3 is equal to minus root 3, correct? From this, what we get? Mod of root x minus 3 can't be negative. This is rejected. Output of modulus function equal to a negative number is not possible. Mod x equal to minus 1 is not possible. Modulus function ranges all positive real numbers including 0, but can't be negative. Mod of root x minus 3 equal to minus root 3 is impossible for any real values of x, correct? So from this, if you remove the mod, I get root x minus 3 is equal to plus or minus 2, correct? Or I can do squaring on both sides also. I'll write this as plus or minus 2. Either it is 2, or I'll write root x minus 3 is equal to minus 2. From this, we get two cases, because mod of 2 is 2, even mod of minus 2 is 2. Both the value satisfies. From this, we get root x is equal to 5. Root x is 5 means I get squaring on both sides. X is equal to 25. Here, root x is equal to minus 2 plus 3, 1. Root x is 1, so x is equal to 1. So, they told alpha and beta are the roots with alpha less than beta. Alpha should be smaller, beta should be bigger. Take this as alpha and this as beta. Okay, so alpha is 1 and beta is 25. So, what we have to find is root of beta by alpha. Beta is 25, beta should be greater than alpha, correct? So, root of 25 by 1 plus root of 1 into 25, correct? Root of 25 is 5, 1 into 25 is 25, root of 25 is 5, 5 plus 5 is 10. Option 3, question asked on 23rd of January 2026. Please make a note. By careful observation, we could complete the square and write the in terms of quadratic in mod of root x minus 3. Please make a note of this. Next, question number 7, we have a word problem here. A building construction work can be completed by two masons A and B together in 22.5 days. Mason A alone can complete the construction work in 24 days, less than Mason B alone. Then Mason A alone will complete the construction work in how many days? So, word problem connected to quadratic equation. Okay. So, let x be the number of days taken by Mason A, and x plus 24 will be the number of days taken by Mason B, because Mason A is going to take 24 days less than Mason B to complete the work. Let x be the number of days taken by Mason A. Let x be the number of days. X be the number of days taken by Mason A to complete the work. Okay, so that x plus 24 will be the number of days. X plus 24 is the number of days taken by Mason B. Okay. And if x is the number of days taken by Mason A to complete the work done in 1 day by Mason A is 1 by x. Therefore, work done, assuming uniformity, okay, work done by Mason A in 1 day is 1 by x. Similarly, work done by Mason B in a single day is 1 by x plus 24. 1 by x plus 24. And overall, we can write the time taken, the work can be completed by two masons A and B together is 22.5 days. So total days taken by both A and B to complete the work is 22.5 days. So I can write the work completed together by both A and B in a single day is 1 by 22.5. So according to the question given the mathematical form, I can write it as 1 by x plus 1 by x plus 24 is equal to 1 by 22.5. 22.5 is 45 by 2. Correct? 1 by 45 by 2. 1 by 45 by 2 is 2 by 45. Here you take common denominator x into x plus 24. So this becomes x plus 24 plus x. This is 2 by 45. Cross multiply and simplify. X plus x is 2x. 2x plus 24. 2 times x plus 12 I can write. Divided by x into x plus 24 is equal to 2 by 45. 2 cancels. Cross multiply. 45 into x plus 12. 45 into x plus 12. This 2 and 2 cancels. 45 into x plus 12 is equal to x into x plus 24. X into x plus 24. Correct? So we can write this as 45x. 45 into 12, that is 540 is equal to x square plus 24x. Or you can write this as x square 24x minus 45x minus 21x plus 540 equal to 0. To solve this quadratic equation, adding you should get minus 21, multiplying you should get minus 540, sorry, minus 540, not plus 540, it's minus 540. Writing 540 to other side, it becomes minus 540 equal to 0. So you can factorize this as x minus 36 into x plus 15, correct? That minus 36 plus 15 will be minus 21, minus 36 into 15 is minus 540. So this gives x equal to 36 or x is equal to minus 15. X equal to minus 15 is not possible, correct? So x be the number of days taken by masonry. Number of days taken can't be negative. So 36 is accepted, minus 15 is rejected. So number of days taken by masonry to complete the work is 36 days. Please make a note. A word problem connected to quadratic equations. On to the next one. Question number 8. Again, finding the number of roots of the given equation given in terms of modulus function. Where modulus function becomes 0, such points are critical points. Mod x plus 3 becomes 0 at x equal to minus 3. Mod x minus 1 0 becomes mod x minus 1 becomes 0 at x equal to 1. So the critical points you can mark like this: minus 3 and 1. Minus 3 and 1. I can discuss 3 cases: x less than minus 3, x between minus 3 and 1, x greater than 1. Correct? Case 1, x is less than minus 3. Case 1 we have x is less than minus 3. X is less than minus 3. For x less than minus 3, suppose we take minus 4. Minus 4 plus 3 is minus 1, negative. Even if you put minus 4 here, minus 4 minus 1, minus 5, negative. So when you take a number less than minus 3, x plus 3 is negative. So mod x plus 3 becomes minus of x plus 3. So it becomes, given equation becomes minus x into x plus 3. Correct? X minus 1 is also negative for x less than minus 3. So mod x minus 1 is minus of x minus 1. Minus of x minus 1. Correct? Minus 2 is equal to 0. So what we get from this? Minus x square minus 3x minus x minus 4x. Correct? Minus x square minus 3x minus x minus 4x plus 1 minus 2, which is minus 1, correct, equal to 0. Or you multiply the entire equation by minus 1, you get x square plus 4x plus 1 equal to 0. Correct, no? Minus x square minus 3x minus x minus 4x plus 1 minus 2 minus 1. Now we can find the roots of this equation using the formula method. X is equal to b square minus 4ac is of course positive only. Minus 4 plus or minus root of b square is 16 minus 4 into a into c divided by 2a, 2 into 1. 16 minus 4, b square minus 4 into 1 into 1, correct? No? 16 minus 4 is 12, root 12 is root of 4 into 3, 2 root 3. So what you get is minus 4 plus or minus 2 root 3 divided by 2. So what you get is minus 2 plus or minus root 3. If you take minus 2 plus root 3 is 1.732, minus 2 plus 1.732 is minus point something, which is less than minus 3 is not possible, it is greater than minus 3. Here minus 2 minus root 3 satisfies. Minus 2 minus root 3 is minus 2 minus 1.73 minus 3.73, which is less than minus 3. Here x equal to minus 2 minus root 3 is approximately 1.732 minus 2 minus 1.732 minus 3.732, correct? It is a number less than minus 3, so satisfies. X equal to minus 2 plus root 3, if you take, it is not less than minus 3, it is greater than minus 3, so that is rejected. So one root we get in this interval. Next case, you take x to lie between minus 3 and 1. If you take a number between minus 3 and 1, say 0, you take 0 plus 3, 3 positive. So mod x plus 3 becomes x plus 3. 0 minus 1 is minus 1. So mod x minus 1 becomes minus 1. Minus of x minus 1. Case 2 we have for x to lie between minus 3 and 1. Minus 3 and 1. So if you take a number between minus 3 and 1, say 0. 0 plus 3 is 3 positive. Mod x plus 3 becomes x plus 3. X into x plus 3. Correct? So here if you take a 0 minus 1 is minus 1. So term sense the mod is negative. So mod x minus 1 is minus of x minus 1. Minus 2 is equal to 0. Solve this equation. X square plus 3x minus x, that is plus 2x, plus 1 plus 2 plus 3 equal to 0. Correct? X square plus 3x minus x, 2x plus 1 minus 2, sorry. Plus 1 minus 2, that is minus 1 equal to 0. Correct? Minus of minus, plus 1 minus 2. So here you find the roots of this equation using formula method. X is equal to minus 2 plus or minus root of b square 4 minus 4 into 1 into minus 1 divided by 2a. So what you get is minus 2 plus or minus 4 plus 4 is 8 divided by 2. Correct? Root 8 is 2 root 2. So I'll get x is equal to minus 2 plus or minus 2 root 2 divided by 2. Correct? Which is minus 1 plus or minus root 2. Minus 1 plus root 2. That is minus root 2 is 1.414. Minus 1 plus 1.4. That is 0.4. 0.4 lies. Minus 1 minus root 2. Minus 1 minus 1.4. Minus 2.4. Even that lies. Both the values satisfies. Both of this belongs to the interval minus 3 to 1. Correct? Both the roots lies. Root 2 minus 1, that is 1.4 minus 1.4. 0.4 lies here. Correct? Even minus 1 minus root 2. Minus 1 minus 1.4. Minus 2.4 also lies. Both the roots lies. Here one root we get. Here both the roots we get. Totally we got 3 roots so far. Last case I discussed for x greater than or equal to 1. X greater than or equal to 1. Say number 2 you take. 2 plus 3 is 5 positive. Mod x plus 3 becomes x plus 3. 2 minus 1 is 1. So mod x minus 1 is x minus 1. So I'll add one page and discuss the last case. Case 3. That is for x greater than or equal to 1. For x greater than or equal to 1. What we get? The given equation becomes x into x plus 3, x into x plus 3 plus x minus 1 minus 2. X minus 1 minus 2 equal to 0. That is x square plus 3x plus x, that is 4x minus 3 is equal to 0. Here you find the roots of this equation. X is equal to minus 4 plus or minus root of b square minus 4ac divided by 2a, which is minus 4 plus or minus 16 plus 12, which is 28 divided by 2. Root 28 is root of 4 into 7, which is 2 root 7 minus 4 plus or minus 2 root 7 divided by 2, or it is minus 2 plus or minus root 7. Root 7 is a 2 point something. 2 point something minus 2 is point something. That does not lie for x greater than or equal to 1. And if you take negative value also does not lie. Here x equal to minus 2 plus root 7. Another value is x is equal to minus 2 minus root 7. This is negative value, can't be greater than or equal to 1, does not belong to the interval 1 to infinity. Even this does not lie in the interval 1 to infinity. So both the roots are rejected. Both are rejected. Both roots are rejected. So here we don't get any roots. In the previous case, here we get 2 roots, here we get 1 root. The number of real solutions of this equation is 3. That is option 1. Please make a note of this. On to the next one. Question number 9 we have. The smallest positive integral value of a for which all the roots of this equation are real and distinct is equal to how much? This is a biquadratic equation. That means the polynomial of degree 4 is given on LHS. Correct? So the given equation is x power 4 minus ax square plus 9 equal to 0. Put x square is equal to t here. Put x square is equal to t. Therefore, the given equation becomes x square is t. So x power 4 will be t square minus a into x square is t plus 9 is equal to 0. This is called equation 1. This is called equation 2. You want to find roots of equation 1, not roots of equation 2 actually. Because I made a substitution, I got like this in terms of t. So equation 1 should have real and distinct roots. That means equation 2 should have positive and distinct roots. Because x square is t I put, no? X square is equal to t. Correct? T can't be negative. Correct? Because x square can't be negative. X square should be positive. X square positive means x square should be, t should be positive. So, equation 1 has real and distinct roots. Equation 1 has real and distinct roots. Real and distinct roots. Means is same as equation 2 has real and positive roots. Okay. For real roots, positive and distinct roots, not real and positive and distinct roots. Alright, has positive and distinct roots. has positive and distinct roots. For distinct roots, the condition is b square minus 4ac should be positive. Correct? For distinct roots, what we have, b square minus 4ac, that should be greater than 0. b is minus a square minus 4 into 1 into 9, that should be positive. Correct? That is a square is greater than 36. That means a is greater than 6 or a is less than minus 6. Okay, one solution we get here. That means a belongs to the interval, that is a should belong to the interval minus infinity to minus 6 union 6 to infinity for distinct roots. For positive roots, both the roots should be positive, means sum of the roots should be positive and the product of the roots should be positive. Alpha plus beta should be greater than 0. Alpha plus beta is minus b by 4. This minus of minus a divided by 1, that is minus of minus a divided by 1, that should be greater than 0. That is a is greater than 0 and alpha into beta is greater than 0. Product of the roots. Product of the roots is c by a, 9 by 1, 9. That is anyway positive, which is true always. Is true always, means for every real number it is already true. So a is greater than 0. This is one condition I am getting. Another condition is a should belong to this interval. Intersection of these two, and means intersection of these two will be a belong to 6 to infinity. This is the 3 I'll call. This I'll call 4. 3 intersection 4 gives. 3 intersection 4 gives. Intersection is common because and means common. So a should belong to the interval 6 to infinity. A should belong to the interval 6 to infinity. In this interval, the smallest positive integral value of a is 7. In the interval 6 to infinity, smallest integral value of a is 7. Quite simple question. Please make a note of this. The given biquadratic equation is reduced to a quadratic equation and modifying the condition too. Here it has real and distinct roots. Here the roots are distinct and positive because I made a substitution x square equal to t. X square can't be negative, so x square should be positive, so t should be positive. Next one, question number 10. Alpha, beta, where alpha less than beta, the roots of this equation, such that 1 by alpha minus 1 by beta is 1 by 3. Sum of all possible values of lambda I have to find out. Alpha is less than beta are the roots of this equation. Okay, so given equation is lambda into x square minus of lambda plus 3 into x plus 3 equal to 0. Because alpha and beta are the roots of this equation, I can write alpha plus beta, sum of the roots is minus coefficient of x by coefficient of x square. So minus lambda plus 3 by lambda, that is lambda plus 3 divided by lambda. And the product of the roots is constant term divided by coefficient of x square, which is 3 by lambda. The given condition is 1 by alpha minus 1 by beta. According to the question given, 1 by alpha minus 1 by beta is equal to 1 by 3. Take common denominator alpha beta. So what you get is beta minus alpha is equal to 1 by 3, taking common denominator. So alpha into beta we know. I'll do squaring on both sides. Squaring on both sides, this becomes beta minus alpha the whole square. Also I'll cross multiply this simultaneously. So alpha beta the whole square divided by 3 square is 9. Beta minus alpha the whole square could be written as beta plus alpha the whole square minus 4 alpha beta, correct, is equal to alpha beta the whole square divided by 9. Beta plus alpha, same as alpha plus beta, which is lambda plus 3 by lambda. This is lambda plus 3 divided by lambda the whole square. minus 4 into alpha into beta is 3 by lambda is equal to alpha into beta is 3 by lambda. 3 by lambda the whole square is 9 by lambda square divided by 9. Correct? Go on, simplify this. Lambda plus 3 the whole square divided by lambda square minus 12 by lambda. Correct? 9 cancels. We get 1 by lambda square. Taking common denominator, lambda square. This is lambda plus 3 the whole square minus 12 lambda is equal to 1 by lambda square. For lambda not equal to 0, you can cancel it. Okay. For lambda not equal to 0, you can cancel the denominators and simplify it. If you cross multiply it, otherwise lambda square into lambda plus 3 the whole square minus 12 lambda, correct? I'll write in the next page. There's no space here. Lambda plus 3 the whole square, you can expand it. That is lambda plus 3 the whole square is lambda square plus 9 plus 6 lambda. Lambda plus 3 the whole square minus 12 lambda divided by lambda square is equal to 1 by lambda square. That is what we get, lambda square minus 6 lambda plus 9. Correct, no? Beta plus alpha the whole square divided by beta minus alpha the whole square equal to alpha beta the whole square divided by 9. Beta minus alpha is beta plus alpha the whole square minus 4 alpha beta. This is lambda plus 3 divided by 3 minus 4 into 3 by lambda. Here it is alpha beta, that is 3 by lambda the whole square. 3 by lambda whole square is 9 by lambda square divided by 9. 1 by lambda square. Correct, no? This we can cross multiply this. Lambda square is equal to lambda square. So that lambda square is common. Lambda square, if you take common, you get lambda square minus 6 lambda. 9 minus 1 is 8 is equal to 0. Lambda square 0 means lambda equal to 0, one possibility. Another possibility is lambda square minus 6 lambda plus 8 equal to 0. So we can factorize it. Lambda minus 2 into lambda minus 4 equal to 0. Which gives lambda is equal to 2 or lambda is equal to 4. Therefore, sum of all possible values of lambda they ask. They ask to find sum of all possible values of lambda, which is 6. Therefore, sum of all possible values of lambda. Sum of all possible values of lambda is equal to 2 plus 4 plus 0, which is equal to 6, which is option 1. Please make a note. Question asked on 28th of January 2026, JEE morning shift. Totally we had 10 questions here. One question was on location of roots. Okay. One question was from a word problem. One question was asked based on the nature of roots. This is a question based on relationship between the roots and the coefficients. This question is based on the nature of the roots. Okay. This question is based on finding number of real roots. This is a word problem. This is relation between roots and coefficients I can tell. Okay. Or just solving the equation and getting the answer. Okay. Of course, we use quadratic equation and solve. Okay. This is relation between roots and the coefficients. Okay. Number of real roots of the equation. This is based on location of roots. This is question on relation between roots and the coefficients. Okay. And this is solving the given equation. Totally we had 10 questions. Okay. If you want to list out this, which is not given here actually. So location of roots, one question. Location of roots, we had one question. Nature of roots, one question. Nature of roots. Word problem, we had one question. One question we had on word problem. Then we had finding real roots. 4 questions we had. Finding real roots or sum of the roots of those things. We had 4 questions. Relation between the roots and the coefficients. We had 3 questions. Roots and the coefficients. Altogether we had 10 questions. So all the 10 questions have been solved completely in this session of quadratic equations. Many more videos will be uploaded in the coming days. Please subscribe to my channel and forward to your friends. Thank you.